Hi, I'm going to show you a little bit about creating what's called an orthographic projection drawing, sometimes also referred to as an engineering drawing or a working drawing for an object. This method uses a strategy called the 9-line method, and I'm just going to explain to you how that works now. So this drawing here is just an example of how different drawings connect. So up here we have what's called an isometric view, and you can see that we've got a blue surface, an orangey red colored surface, and a yellow surface, and they represent the different facets of our object or the different views, and they connect with our other drawing over here. So when we talk about orthographic projection in Australia, we use the third angle projection, and this surface here is always referred to as the front view. That's this surface here as well. Okay, it doesn't really matter how you view the object. If you might be thinking, oh no, but the yellow is obviously the front. It doesn't really matter. We always refer to this sort of corner here as the front view. And you can see with my green lines that I've projected lines up. Okay, and I've then been able to draw in the information that you see on top as the top view. So we have the front view, we're projecting up, and we've got the top view. From the front view, we can also project across to create the side view. This is the right side view, and in third angle projection, we always use these three views. We don't go and create the left side view or the underneath view or any of the other views. It's convention to just use these views that I've showed you here. I'm going to take you through now the whole process using a different object. Let's get started. Okay, so to start with, we need to have an isometric object or an object that you're planning on drawing worked out in your mind. It's also really important that we've got all of our dimensions ready to go, and if you can draw it one-to-one, that's good. If you can't draw it one-to-one because the paper you're drawing on is too small, you need to think about how you can scale it down or scale it up to make it fit on your page a little bit better. So this is the objects that we've got here. Can you pick out which surface, I should say, we're going to call our front view? All right, so to start with, we're going to use our general dimensions to create the 9 lines. Now, the general dimensions are the overall dimensions. So one of those dimensions is 59. I can't recall offhand exactly what this length of the line is, but you can work that out by going 45, 59 plus 15. Okay, so it's going to be around 119 millimeters or something, that sort of size. And then our height is going to be 38 plus 19. So those are our general dimensions. So we start by drawing in order of the lines that I've got here. I always start using that left-hand edge, line 1, line 2. That gives me the starting point for my front view. I can then measure across, okay, to give me the heights that I'm going to work with. This gap here is purely just defined by the spacing that I want to separate my drawings out with. Line 7 is always a 45-degree angle line, and it always comes from the outermost corner of our front view. That'll make a little bit more sense as we continue on. Okay, so we're going to use the information to draw in the front view. I want you to really imagine what that's going to look like for a moment. Okay, so I've gone and drawn that in there, and this is accurate using measurements. Okay, I don't have any of the measurements written on there yet, but hopefully you can see the connection between the front view and the view that's expressed in the isometric. Now we're going to project lines representing the specific information into the top and side spaces. So we've already got the general spaces mapped out. We're going to project those lines, and it should look something like that. With that information, we should be able to now draw in the top view. Okay, now the whole purpose of the 45-degree line, that line number 7 that you see, is to bounce lines off. So you should be able to see here, this line shooting through here comes across, it hits our 45-degree line and it drops straight down. Line number 4 comes across, it hits our 45-degree line and it drops straight down. So you can see, using both the front view and the top view, with this 45-degree line, we should be able to project pretty much all of our lines. So we're going to project those last pieces of information and draw the end view. That's that last bit of information. It's projected across to the 45-degree line and it drops straight down. Just be careful, there's quite a few lines happening over here in our end view now, and you really want to make sure that you have a clear understanding of what the view is going to look like. And there you go, it looks like that. Now the dotted line that you see is actually what we call hidden detail. So that dotted line is actually representative of this join that's occurring in here. We can't see it from our end view, but it can be represented as hidden detail. Alright, lastly, you want to label your drawing and you're finished. Couple little pointers. The subheadings always go, or I should say the labels of the drawings, always go underneath the drawing. They never go on top or beside. You can center justify them as I've done here, or you can left justify them. That doesn't really matter, it's all just preference. Dimensions always go to the side and above the object. They never go underneath the object, because that's where our labels go. And you don't want to over dimension your drawing. So if you don't need to put in extra numbers, extra dimensions, you shouldn't be doing that. It just over clutters it. I hope that helps.